It's ironic that you quoted the Cueto or Omar report. Jose Enrique, how does it feel to be quoted? It feels nice. Jose Enrique was the one that developed that study that indicated the billions of dollars that was estimated. I don't know if you met him over there.
Yeah.
But it's good to see that the seed is growing.
And he wants to demonstrate the toilet for all of us.
So, okay, we'll open it up to question.
Yeah, congratulations. I think this is a very innovative approach. However, I believe it's very challenging to implement. And when I say challenging, there are many things that are challenging to implement this, and especially in an urban setting. And then what I see to be really difficult is the acceptance of, the general public to implement this and in their own home. One question that I have is this, and I was surprised that you didn't, not surprised, I think that probably you should have say here is, before you make a recommendation for the full implementation, I was wondering why you didn't recommend it like a pilot project in a specific area, rather than going and trying to make a full implementation of the system. And I'm just wondering why you didn't.
First, I'd like to address the acceptance issue of implementing such a technology. I think if somehow the leaders of the island could convince the population that trying out new technology is a good thing, Cuba will become an economic innovation hub. So Cuba won't be seen as this, desolate, primitive type of agricultural economy. It will be seen as an innovative economy. So where companies can go in to get new ideas. By implementing such technology, it's kind of a synergistic effect. If the population accepts one new idea, you're going to start seeing new generations, young people, starting to talk about new ideas. So it stimulates a whole different type of philosophy or mentality for the island. Now, for the issue of, I'm sorry, the second part of your question?
Yeah, what I'm saying.
The pilot program?
Yeah, the pilot
Okay,
program.
so the issue is actually urgent and it's pressing. There might be a chance that we can implement a program to test to see how it would work. It is a good idea. But as of right now, they're polluting the water they're drinking. As time passes, the situation gets worse and worse, and it gets more and more difficult to correct. So given the analysis that has been done, we feel that there really is no negative to implementing this type of technology, especially if you open it up for the free market. The free market takes this concept, and they can develop it and design it in a way that caters to different populations. So what the poor people can have like a more economical version of this, whereas the more wealthy people can have a very elaborate design system. Where they basically don't have to do anything. They do the same thing they do with a regular toilet, they just hit a button. So it's something that has a lot of flexibility.
Yeah, I had two observations. I think maybe following up, I guess, on his thought is that I think that's a great application for sort of a suburban agricultural area, because you get a direct tie-in, especially in Cuba. A lot of people have their own gardens because that's one way that they survive or generate money, because they sell the produce that they grow. So, if you created fertilizer, that is a complete tie-in there. Also, it's a low-tech approach to solving part of the problem. I think the point is I guess in the urban area, the logistics become a problem. In other words, the logistic of collecting the material. My question was, did you find some other underdeveloped country or area that has tried to sort of implement this in an urban setting, and how did they make it work?
We use Venezuela as a model. Okay. So in urban settings or dense population areas, they have solid collection services. Basically, we used Venezuela to calculate how much it would cost for Cuba to have a system that would collect the fertilizer from the dense populations, from the cities. And that was included in the paper. We don't have the data actually on the slides. But we discussed the infrastructure, and Antonio has a bit more to say about that.
Well, yeah, the benefits of applying it to the urban setting is that there's a lot of people there. So that's a lot of produce that could happen, a lot of products. And we would tailor this design to be optimized for the urban setting. So the whole getting Cubans to use this technology we would design this to be aesthetic, not just a box. It needs further aesthetic design. We would design it to be ergonomic, easy to use, easy to handle, and it would be an easy transition. Now, there's a lot of benefits that people also don't realize. I mean, that's never going to get clogged, for example. So I think people are going to be looking forward to that. You know, that's another thing to get off your head. And it's very low maintenance. You just have to pull out that drawer and empty it every once in a while. If it gets to a point of it still isn't accepted technology, maybe people think it's too hard to empty out the drawer or something. We also calculated the fact of services, maybe someone coming around and collecting it, similar to municipal waste, like trash and stuff like that. It will be a similar service. But the also other benefit is the compost toilet is designed to contain a lot of compost, and that means this is it's not similar to trash. Trash gets picked up a lot in order to be considered like a clean neighborhood. This wouldn't have to be dealt with that often. It's a once in a month, and it could be designed to be once in a year. It could contain a lot of compost in there, because composting in general reduces the matter. You put in a lot of fecal matter in there, it comes out with a lot less, because the CO2 evaporates, goes away as a gas, and water evaporates. All that's left are nutrients that can be applied directly to agriculture.
Can you scale that up? In other words, I mean, you know,
Yeah,
like,
so
like in Havana, in an urban setting, you know, you have density and you have multiple level buildings. Maybe impractical to put it in each apartment or something, but maybe the apartment can have it.
Okay.
You know, how does that work, scaling it up?
Well, there's many designs possible. We decided to do this because they're personalized units. There's also the design possibility of many small units that all lead to one big container.
Uh-huh.
The issue of that we found for urban settings is that would require construction, a removal of a street to bury that container, sort of like a septic tank. So we stuck to this because it was simple to implement. You just remove the old toilet, you put that where it was. It takes up the same amount of space. So it was simple, but it could be optimized to hold a lot more, and all the fecal matter could be in one container, and that could be implemented in suburban and rural areas also.
You were mentioning the apartment buildings. If the owner of an apartment building is interested, he can have each toilet be connected to a chute system. So whereas once the fertilizer is done being produced, the toilet can automatically empty itself into the chute system. So basically, I mean, if it was a multi-story building, they'd all be attached to one wall where the chute system would be located. So I mean, that's another possibility.
I'd also like to point out with the question of third world countries that this is not just a remedial solution to be implemented in third world countries. You can apply it to Venezuela, which is the example we use, but there are countries, it's in U.S. and there are countries as advanced as Sweden who are using them not only in the home but also in public sectors, in national parks, and etc. So.
One, congratulations, because you got us to think out of the box or out of the litter box in this case.
No problem.
But what has happened here with the audience, it went from, will this happen, to how will you make it work? All of a sudden the conversation is, do you use it in a rural and a suburban type of environment? So it's a much more of how you do it. I would have actually come out from the industrial sector. You put this thing, you start off in jails, you start off in companies, you start off with, you got a magic infrastructure already in place for replacement. The other thing that I would highlight is exactly what you said, is that, look, this only has to be once a month, once a year consideration, so it's not like every day you're pulling the thing out and going through it. It changes dramatically the concept of the removal process of it. If you think 15 years ago, the notion that we would be recycling our cans and our papers and everything else, that was completely foreign to us. So you embellish the idea. One of the things that I would propose, if you haven't done so already, is do a patent search, protect the idea, and start working with the industries that could elaborate on something like this. I'm not sure if anybody's come up with a design like this, but start thinking of the business in front of this, because you clearly have come up with something very, very unique and have put an awful lot of concept behind it.
Thank you.
Any more questions? Pete?
Yeah, there's just a few comments. Number one, an excellent presentation. Your written report was good, this was better.
We concentrated more on the concept here because we didn't want to.
It was much better in getting the point across.
Right.
It was well done. It was entertaining. The Dali, I'm assuming is to turn the crank on the drum.
Sure.
On public acceptance, it's gross. But there's something else that is going on today. In today's wastewater treatment technology, we're actually treating it to the point that you can drink the wastewater. And that is also an issue of acceptance, what is happening in some places today. You mentioned Venezuela. Are they actually collecting it in Venezuela?
No.
With municipal solid waste?
Well, the reason why we're using Venezuela as a model, we want to predict how much it would cost to have a service to pick up the fertilizer, how much it would cost the country. Right now, Venezuela collects regular waste, like food you don't eat or plastics, things that people throw away. Like we do here in the United States, we have solid waste collection. But we didn't use the United States as a model because we can spend more on picking up, but we have technology that picks up the garbage cans and throws it into the garbage truck. But Venezuela doesn't. Venezuela is very close to Cuba when it comes to collection technology for the solid waste. So what we did was we used them to calculate how much it would cost the island to provide a service for collecting the fertilizer. So it was just for that analysis.
Also,
so that's not done yet.
Also, to address the first part of the question of the benefits of traditional water treatment, okay, the major benefit that composting does is that whenever we discover a new pathogen or a new contaminant that we don't know how to handle, there's a lot of engineers out there going crazy on how to filter it. The composting toilet, it keeps it sequestered. It's no longer in aqueous traveling all around and contaminating our drinking water. So by having it in a solid waste, as solid, we could treat it locally and we won't have to worry about new contaminants and their future chaos.
Like I said, EPA is enforcing new standards, which is predicted to cost between $1 and $4 billion. So we don't see water treatment facilities as an economic approach. We're having extreme difficulty with that in the United States, which is a developed high-tech country.
If you were given the opportunity today to do a pilot, what application would you select right now?
To do a pilot, as in
As
the
a pilot,
US?
if somebody here would say, well, I'll give you the financial support to do, 200 units.
Okay, well, the technology already exists for the most optimal cases. For example, getting pipes into national forests, stuff like that. So the technology exists there. It's very useful. So that already is one place where it'd be really easy to implement. Just because we can't get pipes to that kind of area, it's very rural. So in rural sectors, it's easy. And then also for, do you have any?
Yeah, I have something to say. The technology is there. I don't think resources need to be spent, monetary resources need to be spent on technology so much. I think it has to be spent on changing public opinion. So what I would suggest is to have a pilot study, but in universities, so that students can use this technology and later they can use their voices to spread the idea that compost toilets are actually something that we can do.
You put it in the dorms and you...
Right, in the dorms or in all buildings, and people start using that as a way to transfer the idea. That's what a lot of companies do. A lot of software companies, they give the programs free to the students. So then later when they go into the labor force, they buy them because they see how viable they are. So I think universities would be a good start for the technology.
I don't recall if you have this statistic in your report, but I presume you still need water treatment facilities for showering,
Yes.
et cetera. So by what percentage does this type of system reduce the needed capacity of water treatment in an urbanized area?
Okay. The statistic is 27% of the household water use is just your toilet. That's we're not factoring in showers. We're not factoring in rinsing your hands. We're not factoring in brushing your teeth, watering the lawn. So 27% is wasted on just flushing away your, I don't even know, maybe a liter of, not even a liter, just insignificant amounts of fluids and solid waste.
And in the case of Cuba, they do have some water treatment infrastructure.
4%.
So by eliminating this additional burden, does the infrastructure they have still need to be improved?
I would say it's cost deficient to improve a system that only filters 4% of their waste effectively. It's an antiquated system. It's over 100 years old. It's not meant to supply to the level of population, to the number of population living in, for example, Havana. And that's in the case of densely populated areas. Let's not consider cases where there is no infrastructure and you would have to implement something brand new, like something complete. So.
I want to add that I actually used a toilet like this in Cochabamba, Bolivia, when I went on a Water for People event, and they were using it to fertilize champiñones, mushrooms, and it was very exquisite mushrooms. So it was sustaining the economy of this very rural area. So there were no odors. I can vouch for that. There's usually a vent to release the CO2. But I have one question for the team. What happens to number one?
Okay, go ahead. So, for urine, urine's actually considered to have low amounts of pathogens. So, the treatment there isn't as critical, but it's still treated here. You would use it normally. So, all urine will go in there in the tank. The tank has, even toilet paper goes in there. That's considered a bulky material. So, it'll compost. But yeah, the urine will go in there, and the tank has holes in them, like a little mesh that would drain out the urine to control the humidity levels. Too much humidity and there's no composting. Too little humidity and there's also no composting. At least not efficiently. The composting will occur, but not efficiently. So the urine is also treated, and we take advantage of the nitrates and stuff like that that come from the urine. They would then, after they drain through the compost drum, they would end up in the bottom panel of our toilet design, and that would be considered an evaporation pan. We've considered installing heating elements if it's necessary to speed up evaporation, but we're hoping for a natural evaporation through the vent in the back, and we would take advantage of the nutrients in the urine, and we would evaporate the excess water.
Can I emphasize a point? I like to emphasize...
Your tagline could be, we're number one at number two.
Yeah, it's a good marketing term. But I'd like to emphasize that this is actually a closed system. If you analyze it, it's closed. What happens today is that we grow crops and then we consume them, right? We take out the nutrients that we need, and the rest of the nutrients gets filtered out and it's considered garbage. But if we actually start implementing this type of technology, it becomes a closed system because we take the nutrients from the crops, ingest it, use it, then once we can't anymore, we get rid of it in our waste, human waste. It goes back into the field. So basically the nutrients are constantly recycled. A big problem that we're facing today is that our fields are being depleted of nutrients. So if you grow corn for 10 years on a certain piece of soil, after that, you're probably not going to be able to grow corn as fast, as economically, etc. So this will eliminate that problem because, again, it goes back to a closed system.
And supply of artificial fertilizer.
So how often?
Yeah, we're using oil now to supply nutrients.
So how often do you have to turn the crank?
It all depends on the optimization of the design. So in an urban setting, since it's a small toilet, and we calculate the volumetric capacity of the drum. The drum, if you don't empty it at all, for the entire year, it would hold the fecal matter for 3 to 4 people.
Yeah.
If you empty it, you would never have to worry about it filling, and so you can empty it at the pace you want. So the trick is you use the handle to align the drums, and that will separate. So for in an example, in 1 week you would do that, and then you have final compost in the bin. You'll give it another week, and the bin will desiccate that compost, further eliminating pathogens. The next week, instead of turning the crank to put more compost in the bin, in the shelf, in the drawer, you would empty out that drawer. And it will just be a cycle of that, whatever timeline you want. Even greater, though, is for the case of suburban and rural. And you could have bigger containers, and instead of emptying it out weekly, monthly, you could empty it out seasonally. So you have compost and fertilizer for your fields when it's necessary at the beginning of the season. And you could just do it in that cycle.
Can I just say one more thing?
Yeah, sure.
Okay. I just want to say that the task kind of seems, or may seem daunting, but the leisure of having water flushed down wasn't easy. It was really hard. Right. We admire Roman aqueducts because it was really hard to do. And I feel like this doesn't even measure up to that. So, it's just a matter of, it's like when you take a hard class and you look back, oh, that was, I made it, it was easy. But when you were there, you were suffering. The pride is in getting through the pain. That's what I'm saying.
Good.
Well, I want to echo what Pete said. Just by your response to the questions really shows that you've given this a lot of thought, a lot of conviction, and it shows. So one more round of applause, please.